Welcome everybody. Today we'll be having a small session on PPP, PPPoE. Basically, these are WAN keywords that we handle. Do let me know if you can see my screen.
Yep, it's visible.
Okay, thank you. Okay, so we'll just start with the basics of PPP. So what is basically PPP? PPP is a protocol that was originally implemented to create and maintain direct connections between two nodes. So PPP is what? Point-to-point protocol. And it is a protocol that provides many features, but I think the most interesting feature that is the reason why it's widely used is the ability to authenticate and identify users separately using authentication methods and accounting methods. And then once you have users authenticated, you can obviously put like authorization and accounting into place so that you know which user is consuming how much bandwidth and then apply rules and policies accordingly. And PPP is the base for all these higher advanced implementations of PPP like PPPoE, BPDN, ISG, BNG. So everything is built over PPP. And earlier, I think when it started, PPP was mostly used over ATM interfaces. So it was called as PPPoA, which is PPP over ATM. And when there was a time for it to move to Ethernet, there was a challenge for network designers because Ethernet is a multi-access media by default. And it does not allow the kind of separation per subscriber that PPP requires. So for that, we had something called PPPoE. We will be looking into that later. And so yeah, just to look at the basic features of PPP, it is used in aggregation networks, and then it supports negotiation. You have authentication. You can also configure multi-links for PPP. So basically bundling of links and providing a singular link, multi-link, and then it supports many NCP protocols as well. We will go into depth about all of these features. And basically, PPP also operates only on the data link layer, which is the layer 2. And then there are two phases to that as well. So PPP is broken into two phases. It's actually three, but then if you look at just the data link layer, it's two because it's NCP, which is your network control protocol, and then it's your LCP, which is link control protocol. Okay. So LCP takes care of setting up the link. If you enable authentication for PPP, it will take care of the authentication as well. And once the link is set up, we come into the third phase, which is NCP. And NCP will make sure that you can run like different protocols on PPP like IPv4, IPv6. It also takes care of other protocols like CDP and some very older legacy protocols like IPX or AppleTalk, which we don't really see pretty much these days. Like I've not seen one case on these, but yeah, it was NCP. Basically, LCP sets up the link, negotiates the authentication and everything, and NCP is what will tell what protocols will run over the link, and everything happens on layer 2. So that is how PPP looks. So we will go into all of these phases. I'll just give a brief introduction on how authentication works in PPP. So PPP has two modes of authentication. The first one is PAP and the second one is CHAP. So PAP is password authentication protocol. Here it is very simple. You use plain text password for authentication. So basically we send an authentication request, which will have our plain text username and password. And then the other side, which is, so the client sends the request and the server, the PPOE server will tell you if it is a yes or a no, if it's a match or not. If it's yes, then you get an acknowledgement. If it's a no, then you get a negative acknowledgement. But in CHAP, CHAP is more secure because it's a challenge handshake authentication protocol. It is a three-way handshake. Authenticator will send a challenge, the peer calculates and responds using MD5s, and then the authenticator will also do the same math and compare the results, and then again you'll get the same ACK or NAC. So in CHAP, basically the password is never sent across the wire in clear text. And because the challenge is always random, you can make sure that there is no possibility of any replay attacks because all the MD5 hashes will be unique. So we can make sure that no two passwords are conflicting and there is no sort of identification issues. And the authenticator, which is the PPPoE server, is in control of the attempt and can re-authenticate the peer at any time. So that is just the authentication types. Basically, here what you need to keep in mind is that there are two types of authentication when it comes to PPP. The first one is PAP, the second one is CHAP. PAP is simple plain text authentication, and CHAP is a three-way handshake where we use the MD5 hashing for the password to be sent across. Now we'll talk about the IPCP, which is basically the NCP layer of the PPP, which is the second part. Here, what happens is what happens exactly in NCP is like you'll have negotiation similar to LCP. So in LCP, the first phase, what really happens is you send a conf request, which is basically a config request that, okay, this is my MTU and this is the kind of authentication I want to go on with. That is what happens in LCP. And then the server was like, okay, this is my MTU and this is the kind of authentication I support. Now, based on what the two sides have to offer, only when they have the common parameters, they can go ahead and set up the LCP connectivity. So basically what's negotiated in LCP, just MTU and the type of authentication that they'll take. Either it's PAP or it's CHAP. Now in NCP, what we actually try to negotiate is the kind of protocol we want to work with, like is it IPv4, IPv6. Sometimes we also push attributes like DNS server IPs and basically IP addressing and the kind of IP address that I want, the kind of traffic that I want to flow over this TPP link is negotiated in the NCP phase, which is the third phase. So LCP, the first one where you have MTU and the type of authentication. Then the second part is authentication, which is also a part of LCP, where you actually exchange the username and password. And the third part is NCP, where you negotiate what kind of IP protocol will flow, CDP, or what kind of IP address we'll assign to the client. And if we want to push any other attributes like DNS or a WAN server address. So that is the third, like these are the steps of PPP. And if we talk about PPP, PPP also has a very usable feature called multi-link PPP. So when you look at multi-link PPP, think of something similar like port channels. So it's just basically bundling multiple physical PPP links into one logical link. So even the configuration is the same. You will configure, say, interface multi-link 1, and then you will, and on the interfaces that are running PPP, we'll assign that group number so that all of them are linked to that one particular multi-link. So now all these links that are the part of the multi-link are called member links. And the multi-link itself is called the multi-link interface is called the bundle master. So there can be one or more member links. There is no requirement for member links to be of like identical bandwidth or MTU. And member links can be added and removed on the fly. Like you do not need to bring the multi-links down to add or remove any member link. It can be done while the multi-link is up and functioning. And fragmentation as well on the multi-link is optional. So it's not requirement that all of them have the same MTU size. So it is completely optional. All links can have their own. So it actually just works similar to like port channels. So when you think of multi-link PPP, think of port channels. We'll just go through how PPP actually looks. And what we're looking at is the negotiation that happens in a common PPP, like the packet flow that happens. So what happens first, if you look at this, router 1 is the client and router 2 is the server. So it's always the client that initiates the connectivity. It sends a config request. And when it sends the config request, what does it have? It will have, okay, this is my MTU and this is the kind of authentication I want. So here in the first packet, if you see, the client is saying that, okay, I want PAP authentication. And this config request goes to the server. But the router then sees the packet and then the server is like, okay, I don't want to work with PAP. What I support is CHAP. So I will send a config NAC, which is a negative acknowledgement. And then when the client sees this, and the client is actually configured for both PAP and CHAP. We can also have both PAP and CHAP configured in the client. So the client is like, okay, you don't work with PAP. I do have CHAP authentication as well. So it sends another config request to the server where it's like, this is the packet which has the value as CHAP. And then the server is like, okay, I do accept CHAP. And then it will send a config ACK, which is the proper packet for the session to come up. Once the client receives the config ACK, then it will send another, and then the server sends another config, the server sends another config rec along with the config ACK saying, okay, this is the CHAP protocol that you requested for, this is the packet, and the client again validates it. And then this is when your LCP session is, this is the entire packet flow for LCP. So basically confrec, confnac, confac, these are the three packets that you'll see. And this is the kind of negotiation that happens. And once the last confac is sent, that is when your LCP session is complete. After this, the authentication takes place. And after that, the NCP protocol happens where you negotiate what kind of IP addressing you want, and then an IP address is installed onto the client. This entire negotiation process can be seen in one particular debug that you run on the router. So and this can be run anywhere on the server or the client. So once you run debug PPP negotiation, you see this packet flow. So here, this particular debug is from the client itself. So you see that the first packet is an outbound confrec. And then you get an inbound confrec from the ISP saying like the authentication method that it supports is PAP. And since my client supports that, it will send a conf ACK, and then I get another conf request saying PAP is supported, and then another conf ACK is sent. It is the same what is happening here. And once that is negotiated, it comes into the authentication phase where you have your authentication working. You have your username and password being exchanged. And once that is happening, the phase becomes up. So LCP is basically up right now after the authentication is complete. And then we come to the NCP phase. Here, the IP address is being assigned. So you get an inbound packet from your ISP saying, okay, this is the IP address I want to assign. And then the IP address is negotiated, and then the route is installed for 30001. If you look at the first config packet and the second last line, that is the IP that has been assigned to the provider. We will look into this in our lab as well, so it'll become pretty clear there. But this is how a normal negotiation looks like. Okay, so on the server, so on the client end, the kind of configuration that we have is we'll have a dialer or we'll have an Ethernet address. So when I'm talking about PPP, you'll just have the MTU configured, the username, password configured, and the kind of authentication I support on the client side. On the server side, you'll have a username, password in your global configuration to authenticate that. Then you will also have a virtual template. Basically, what a virtual template does is it clones a virtual access interface for every client. So it will have the basic template or the basic set of configuration it wants to assign to every client. And whenever a connectivity comes up, it will assign a virtual access interface to that particular client. And then the connectivity will come up. And the reason why virtual access interface is actually used is because it consumes very little hardware, so very small footprint for memory, and it is very fast to create and also to bring it down. So which is why instead of using a whole physical interface, we just have a virtual access interface. And that's also easy to identify the subscriber because every subscriber will have one cloned virtual access interface, which is unique to them. So it's based on the server, we just have a virtual template that is associated to the main physical interface that is connected towards the client. And then the virtual template, whenever the session comes up, will assign a virtual access interface that will have the ability to talk to the client. So these are all virtual interfaces. None of it is physical. Even the virtual template itself is a virtual, as the name suggests, it's a virtual interface. And this will be more visible when you actually work on ISDN or async, which will be covered later. So when you go through ISDN, you'll see how virtual templates are more and more usable, even for VPDN, for troubleshooting, because virtual access interface will tell us what attributes or what configuration we're pushing towards the subscriber. Okay, now we're going to talk about PPP-OE. So this is the maximum number of cases that you will get for PPP. Most of them will be PPP-OE. PPP-OE is basically just PPP over Ethernet. So PPP configured over fast Ethernet or gig Ethernet, it's called PPP-OE. Now PPP is just a point-to-point media, as we talked about earlier, right? And Ethernet in essence is a multi-access media. So what the creators of PPP did is that they built two phases to overcome this challenge. The first phase is called the discovery phase, and the second phase is called the session phase. So the discovery phase is what is new, where we have 4 packets being exchanged to bring up the PPP-OE session. And the session phase is what we saw earlier, where you have the confrec, confnac, the LCP, and then the IPCP packets. So it's just the session phase that is new. Sorry, it's the discovery phase that is new, and the session phase is what we saw earlier in the packet flow. And the main goal of the discovery phase is to discover and identify the two ends that are going to negotiate the PPP connection so that it is unique for every subscriber connectivity. And in the session phase, the unique session ID will be used for each PPP-OE client so that the server will be able to uniquely identify the client and start negotiating a separate PPP connection. So this is how a normal topology looks like. So the access concentrator is actually the PPP-OE server, and then the router on the left-hand side is the PPP-OE client. And the PPP-OE session is built over your router and your server. And one access concentrator can be connected to multiple routers and have multiple PPP-OE sessions running over it. This is just like how a normal topology looks like. Now we'll talk about the discovery stage that is there in PPP-OE. So there are 4 kinds of packets that are associated to the discovery stage, which is PADI, PADO, PADR, PADS. And the alternate for PADS is PADT. So we'll just go through it step by step. So if you look at the first packet, the left-hand side is the PPP-OE client, and the right-hand side is the PPP-OE server. And we'll talk about all the steps that happen in the discovery stage. So in the first packet, the PPP-OE client broadcasts a PPP-OE active discovery initial packet. So that is the full form for PADI, which is active discovery initial packet. So PPP-OE active discovery initial packet that contains the kind of service that I want as a client. And after receiving the PADI, the PPP-OE server will say like all PPP-OE servers compare the requested service with the service that they can provide. The PPP-OE servers can then provide the requested service unicast. So the PADI packet is essentially broadcast, but the PADO packet is a unicast packet. So the PPP-OE server can provide the requested service unicast with a PADO packet, which is active discovery offer to the PPP-OE client. Now, once the client receives the PADO, it will, and it can happen that the PPP-OE client receives PADO packets from more than one PPP-OE server, right? Because it sent out a broadcast message. So it's possible there are multiple PPP-OE servers in the network, and it can receive multiple PADOs. So the PPP-OE client will select the PPP-OE server from which the first PADO packet is received. So it does not wait for the other responses. It will just take the first one that it gets, and then it unicasts an active discovery request packet to that particular selected PPP-OE server. So that is how a unicast connectivity is established between the client and the server. So the first packet that it receives, it will send a unicast pad R, which is discovery request, to the selected PPI server. On receiving the pad R, the server generates a unique session ID to identify the PPOA session with the client, and then sends an active discovery session confirmation, the pad S packet, which contains the session ID for the PPOA client. When the PPOA session is established, the PPOA server and the PPOA client enter the session stage. And once you enter the session stage, you can go ahead and it will learn, the client will learn the session ID and the pure Ethernet address, and it will have a unique PPPoE session built up. So after this session is built up is when we can go for the other PPP part that we covered, where it will negotiate the LCP, then it will negotiate the authentication, and then the NCP, and this PPPoE session itself comes up. So no IP is assigned in the discovery stage. The client just discovers the PVPOA server and then establishes a unique session ID that, okay, this is the client, this is the server, and we have a unique session going on between us. So hence this name also, which is called the discovery stage. Now, another kind of packet that we see in the discovery stage, apart from these four, is the PAT-T message, which is not a part of the discovery message, but can be sent anytime by any of the two ends, like either the client or the server. And what essentially it is that the PPOE server and client use PPP to terminate the PPOE session. They use the PAT-T packet. So if the PPP cannot be used, the server and the client will send the termination packet. It can be due to any reason. Either the timeout has happened, or they are not able to negotiate, or they're just not free to respond to any other new session request, is when they will send out the termination packet. And once the session is established, the PPOE client or the server can unicast the PAT-T packet to terminate the PPOE session anytime. And after receiving or transmitting the PAT-T packet, the PPOE session is removed and the session is down. Suppose that the session is brought down and its connectivity is broken. So after the session, once you go through the discovery stage, is when your session stage comes, which we talked about earlier as well. So a conf-rec is sent from the client, and then the ISP sends so the server sends a contact, and then you send another conf-rec, and then you come into the authentication phase where you negotiate your PAP-CHAP username password, and then it comes into the NCP phase where you negotiate the IP address that the client is getting. So I'll just talk a bit about the session stage, which we saw earlier as well. The purpose of this phase basically is to establish the PPP connection between the two ends. In this phase, PPP connection establishment can run normally as if it was running over a point-to-point media. And we know the three phases that are running here: the LCP, authentication, and the NCP phase. The one you can see that on the diagram as well. So the first part is LCP, the second part is authentication, and the third part is called NCP or IPCP. So all PPP negotiation packets will be encapsulated into the PPPoE header. And what does the PPPoE header have? It has the unique ID that we negotiated in the discovery stage, the one that we got using the PAD-I, PAD-O, PAD-R, PAD-S. So the PPPoE header has the unique session ID that we negotiated in the discovery stage. Now, the PPP session stage involves PPP negotiation and packet transmission. The negotiation at the session stage is the same as the common PPP negotiation, which we talked about earlier. So in the LCP phase, the PPPoE server and client will establish and configure a data link and verify the data link status. Here, the MTU and the type of authentication is discussed. When the LCP negotiation is complete, the authentication basically starts. And depending on what protocol you're using, PAP or CHAP, the password is exchanged. Once the authentication exceeds, PPP enters the NCP phase, which is the network control phase. Here we configure the network layer protocols, which is basically which IP version you're going to use, IP version 4 or 6, what IP address is being assigned. And once the PPP negotiation succeeds, the data packets can be forwarded and the link is up. So not to be confused, the first stage of PPPoE is a discovery stage where you exchange these 4 packets, PADI, PADO, PADR, PADS, and a unique session ID is obtained here. And then that unique session ID encapsulates the PPP data frames. And then you come into this phase where you negotiate other things like MTU, or the authentication protocol, and then you negotiate the authentication, and then you enter into the NCP phase where you basically go for the IP negotiation, and then the client obtains an IP from the server. So this slide also talks about the same thing, that PPOE has 2 stages, the discovery stage and the session stage, and this talks about PADI, PADO, PADR, PADS. And once the session is up, you can use a PAD-T, or even when the session is not up, you can use the PAD-T packet to bring down the session. Okay, so I'll just show you a quick lab here. So if you see this is my PPPoE client, and this is my PPPoE server. Now, if you look at the configuration, what exactly do we need on the client? So I'll just highlight that here. So this is my physical interface that is being connected towards the server. Say it's fast Ethernet 00. Now, what is the basically the kind of config that is essentially required? So your MTU should never cross 1500, and because the PPPoE header itself is 6 bytes, so we try to keep the MTU at like 1492, and for that we give the TCP adjust MSS to 1452. It will work without this as well, but it's a best practice to put the adjust MSS to 1452. And so on the physical interface, the necessary configuration is that you will enable PPPoE using the command PPPoE enable, and then you will assign a dialer interface, which is a virtual interface on the client, which will establish connectivity and get an IP address from the server. So if you see that the physical interface itself has no IP address, and it is just associating itself to the dialer 1 using the command PPPoE client dial pool number 1. Now, if you have dial pool number 1 here, you have to have dialer pool 1 here. This is how using the pool number is being linked between the virtual and the physical interface. So now when we come to the dialer interface configuration, we'll have negotiated IP address, because this we get from the server or the ISP. Then the encapsulation is specified, which is PVP dialer pool 1, dialer group 1. And then we'll specify what kind of authentication does the client support. So here, if you see, we are supporting both PAP and CHAP authentication. So obviously the first attempt will be with PAP, because PAP is specified first in the command. And then the second attempt, when it actually receives, if the server does not support PAP and it says, okay, I want CHAP, and then in the second attempt, it will send the CHAP password. Calling just specifies the direction. So basically we are getting an inbound connectivity from the server. And then below that, you will specify the username and the password. So this is the sent user. This is the basically command for PAP and CHAP. So PPV PAP sent username. This is the username in plain text and password in plain text. PPV CHAP hostname password. But CHAP, you obviously are configuring in plain text, but when it is sent across the line, it is using MD5 and it's hashed so that it's encrypted when it travels between the server and the client. So this is the configuration needed on the client. So basically a physical interface that does not have an IP address, we just enable PPPoE on it, and then you have a dial pool number 1, which is linking it to the dialer 1 interface, where you have a negotiated IP address, you have encapsulation PPP, the dialer configuration, the kind of authentication that I want, and then the credentials for the authentication, the username and the password. And on the server, what you have? So on the server, you have the username and the password that we configured there. Then we have the virtual template configuration. Excuse me. The virtual template is what I told about. So this is what gives you, this is what clones a virtual access interface for every subscriber. So on the physical interface, basically that is linked towards the client, we just enable PPP. That is all we do. And then everything happens under the virtual interface. So under the virtual interface, we specify the MTU. We say which physical interface it's linked to. So here it's fast Ethernet 00. Then we assign, so just like how you have a DSCP pool, we also have a local pool for PPPoE as well. So that one of the IP addresses from this pool will be assigned to our subscriber or the client. And then the kind of authentication I support. So here the server also supports either PAP or CHAP. So this is the configuration on the server. So the username, password, then the virtual template configuration, the virtual template itself being linked to the physical interface, and then the pool that assigns the IP address. So we'll just go to the lab. Here, I think it's gig01. So this is the client. So the same sort of configuration that we saw there. The client physical interface will have your PPPO enable group global and the dialer pool number 1. And if you look at the dialer interface, you will see the configuration that we have on the dialer where you have IP address negotiated, encapsulation PPP. Then since you specify dialer pool number 1, we'll link it to the dialer using the same number, which is the sequence 1. Then the kind of authentication I want, PAP and or CHAP both. The username is specified here. For CHAP, this is the command line. And then for PAP, this is the format. And then obviously you'll have a route which will go out through dialer 1. So we've just given a default route right now, which is going out via dialer 1. So this is the config that is needed on the client end. And on the server end, we just enable PPPoE enable group global on the physical. Basically, we're enabling PPPoE on the physical interface. And then we have the virtual template configuration, where we are specify which physical interface it's linked to, the pool that will assign the IP address to the server, and the kind of authentication we support. So here, if you see, I'll just show you. The virtual template that we specified here, because we gave IP unnumbered gig01, it will just show the IP address of gig01. But if you look at the status and the protocol of virtual template 1, it will always be down, and that is expected because it's not the virtual template itself that's establishing connectivity with the client. It clones a virtual access interface with the settings that it has. So if you want to see the virtual access configuration, you will not see it in the show run. You can use a command called show derived, sorry, show derived config virtual access into virtual access 1.1, and then it will show you what kind of, my bad. So basically, it's a virtual access interface that will be talking towards the client. And where is this virtual access formed? It just clones all the attributes that it has in the virtual template interface. Just wait for this to time out. And how do you verify if a PPPoE session is up or not? Right now, I've configured it so the session is up. So the basic commands that we use are, you do a show PPPoE session. This will tell you that the session is up. This is the dialer 1 interface. And then the save type is up. And how do you see what IP is assigned? You can obviously look at issue IP interface brief, and what IP is assigned on the dialer interface will be the IP that we've received from the server. Or the other way to check if the connectivity is up is also to use show caller IP. If you do the show caller IP, you'll see that this is the IP of the server. And this just tells you that we have one call which is active, which is basically the connectivity we have between the client and the server. So show PPPoE session will tell you that the session is up or not. The IP address you can check on the dialer interface, and show caller IP just to verify if the call is established or not. Okay, so just to highlight here, so as I talked about earlier, the virtual access interface, what it does is it will clone all the configuration that it has in the virtual template and then provide a unique interface for communication with the client. And if you look at this, we haven't configured a virtual access interface. It's just cloning whatever attributes we have in the virtual template. And it is the same. It has the IP number, it has the pool, and then it has the authentication protocol that we're specifying. And you can run the same commands here as well. You can have show PPPoE session, and sorry, that will tell you if the session is up or not. And since this is a server, you can see multiple sessions coming up. Right now, we just have one client connected, but you can see multiple sessions here as well. And if we want to see what kind of debugs do we see, so to actually negotiate. So if you remember when we talked about PPPoE, we talked about first the discovery stage, and then we talked about the session stage. Now, if I want to see if the discovery stage is being carried out properly or not, I use the debug PPPoE events and errors. And to check the session stage, I will use debug PPP negotiation. And I'll just do a clear PPP all so that it's slightly better. Right now, since I did a clear PPP all, the neighbor has just been removed and PPP disconnect was sent from our side. And if you see the PAT-T packet that we talked about, since I did a clear PPP, a terminate packet was sent and the interface was brought down. So this is what happens when we try. This is just the PAT-T packet. Now, if you see here, okay, this will scroll up pretty fast. I'll just let it go, then we'll look at the deeper. Okay, let's just look at the debugs. So this is where we enter the discovery stage. So a paddy is sent from, there is some issue. Okay. The paddy is sent from the gig01 interface, and then we get a paddo, which is from the server. If you look at the direction, it's incoming. Once we get the paddo, we send a pad-R for that particular session to that server, and then a PADS is received. After this, the discovery stage is over and the session comes up. Once the session comes up, you see the virtual access interface also coming up. Now, once the PADI, PADO, PADR, PADS has been negotiated and the session stage can begin. Once the session stage begins, what do we see? We see the config packet going out from the client. We get an inbound config which says, okay, I support PAP, and then our client will be like, yeah, we also support PAP. And then authentication phase starts where they exchange the username and the password. And once that is done, we enter into the NCP or the IPCP phase, where my client will send out an address of 0000. But the reason why I send out 000 in my config request is that I don't have an IP address. 000 is a signal for ask. So I don't have an IP address. Please assign an IP address to me. So the moment your server sees 000, it will assign an IP address, and the IP address that is being assigned is 10.10.10.2. And once the IP address is assigned, you'll see that the route is installed for 10.10.2. So if you do show IP in brief, the dialer will have the IP address 10.10.10.2. So this is how the session is come up and session comes up, and then how you check the debugs and what commands you use. So it's pretty simple that way. And if you want to look at the Wireshark captures, if you look at this, you will know that the preview happens only at layer 2 because the source and destination will always be MAC addresses. So if you look at the first packet, it will be PADI, PADO, PADAR, PADS. You can obviously expand these packets to just see what's there. The session ID you'll see in the PADS as well. This is the session, unique session ID that has been negotiated. Then the config, then the authentication request. Then here it's the protocols that are being negotiated, which is the IPCP is just the NCP phase where your IP address and everything will be negotiated. If you look at the last config packet that is coming from the server, you'll see the IP address that is being assigned. So a packet capture will also show you all of these packets, but the easier way to just see it is to run the debugs that I showed earlier. So, I mean, any questions so far? I didn't stop and ask in between, so I'm just gonna ask now. I mean, it's pretty simple if you probably get a case, or if you got a PPP case in the past and you worked on it. So this is how the normal flow looks like. Next two slides just talk about the kind of troubleshooting that you can do. Okay, I'll just cover the troubleshooting, then we'll pause for questions. So first we need to check. So if you get a case and the customer is like, my dialer does not have an IP, or my client has lost its IP, and what do you do? First, you'll check the connection status. So you will run the command show PPP all or show PPPoE session. So if you are on the client, as we talked about earlier, you'll run the command show PPPoE session. Once you see that, okay, right now because my session is up, you are able to see that the session is up, or you can also run show PPP all. Here as well, you can see if it was actually disconnected and you did not have a session in place, then you will see that this particular table will be empty. Also, the PPPoE session here is quite useful because let me see if I can replicate that. Once the indicate 01. I'm just trying to see if I can show you the faulty messages as well. So I've just shut down the physical interface that connects to the PPPoE, so the client. And here I will do a clear PPP all. So I've just cleared the PPP and I've shut down there. So now even when it tries to connect, we'll see what kind of output do we see in show PPPoE session. So this actually, so right now it's shut down because we cleared PPP. Just wait, okay, yeah, this is what I'm looking for. So what happens is on the client, I have my PPP configuration in place, and you know the client initiates the connectivity. The PADI is sent from the client, and so once the PADI is sent from the client, and there are times when there is a network break or the ISP device or the server device is down, so with the connection is not coming up. So when you run the command show PPPoE session and you look at the state type, you'll see it is PADI sent, which means that we have sent the PADI and we are not getting a response from it. This is the last state. After 3 PADI sends, this session will also go down. So if you actually look at debug PVPOE events, it will also show you similar packets. So if you see, we are sending a patty and we get a patty timer expired. This patty timer expired is for the first patty that we sent. And post that, we're trying another connectivity, we're sending another patty, and we'll keep getting patty timer expired. That means that we are sending out the packet. So when you try to isolate where the issue lies, when you run these debugs, when you see this output, you will be able to see that, okay, I'm sending the initiation packet, but I'm not receiving anything in response, and my timer is expiring, which is why we cannot go ahead with the session setup, which is why the PVP is not coming up. So that is the one thing that we can do to troubleshoot this. So this is just happening. This is used when you actually doubt that there is a connectivity issue or it's just stuck in patty. Everything can be seen using the 3 debugs as I told you: patty events, errors, and then debug PVP negotiation. If there is an authentication issue as well, you will see that in debug PVP negotiation. If there's an issue with MTU as well, you see that there. So everything is seen there. So that is what we do when we check the connection status. Now, apart from this, if your connectivity is fine, if you see that it is passing the session stage and then it is getting stuck somewhere in the negotiation phase, sorry, it's passing the discovery stage, but it's getting stuck in the negotiation or the session stage. In that, what do we check? We check if we have the correct sort of authentication configured, do we have the correct username, password configured, and all this has to be checked on both ends. If your MTU is fine, so it has to be the same on both ends as well. And so what kind of IP is being assigned, and then you run the same sort of debug PVP negotiation. You can also run debug PVP authentication just to have more like visibility into the kind of authentication packets that are passing. But yeah, more debug PVP negotiation should give you a fair enough idea if you are getting a conf snack. If you're getting a conf snack, for what reason are you getting the conf snack? So this is all about troubleshooting a PVP connectivity. Yeah, I think I've covered all the topics when it comes to PVPOE. You can let me know if you have any questions now. Stop sharing. Stop the recording as well.